A few years ago, astrophysicist Franco Vazza met his old friend Alberto Folletti, now a neurosurgeon, at a bar. As they caught up, discussing Vazza's research on the structure of the universe and Folletti's studies on the brain, an intriguing idea emerged. Why not compare the two? Vazza, based at the University of Bologna in Italy, took on the challenge. Using statistical analysis, he compared the brain's neuronal network to the cosmic web, the intricate pattern of matter spanning the universe. He examined the number of nodes in each network and the connectivity between them. The findings were surprising. The similarity is amazing, Vazza says. Though the two structures differ in scale by about 27 orders of magnitude, the patterns they form are strikingly similar. For some scientists, this resemblance is hard to ignore. Some have even proposed the bold idea that the universe itself may think or possess a form of consciousness. In a sense, referring to the human brain as a 3-pound universe might be closer to the truth than we realized. When scientists examine two of the most complex and captivating structures known to science, the human brain's neuron network and the cosmic web of galaxies, the resemblance was truly uncanny. How would you react to the thought that the very chair you're sitting on is made up of tiny particles that harness some type of rudimentary existence? How would you respond to the idea that the potted flower next to your chair, as well as the 4 walls surrounding you, possesses an internal mind? What if the world around you was not an inanimate stage upon which you, the owner of a soul, played the lead role, but was instead fully awake just like you? This is called Panpsychism, or the theory that everything has a mind or a mind-like quality. The concept of Panpsychism has been around for hundreds of years. Italian philosopher Francesco Patrizzi coined the term in the late 16th century. The idea dates back even further, though, to ancient Greece, when astronomer, mathematician, and pre-Socratic philosopher Thales said that everything is full of life. And one of the world's best-studied philosophers, Plato, said that the world is indeed a living being endowed with intelligence. The fact that empirical sciences can't explain how matter creates conscious experiences has recently renewed interest in panpsychism. Developments in neuroscience, psychology, and quantum physics have also contributed to this renewed interest. For some, panpsychism offers a simple solution. It suggests that consciousness is a fundamental part of reality, and that all matter, even particles, has some form of basic consciousness. This idea makes it easier to understand how human consciousness arises, as the brain is already made from these basic units of consciousness. Through a series of processes, subatomic particles come together to form atoms, which then combine to create molecules, cells, organs, and entire organisms. These structures represent increasingly complex layers of connections within quantum fields. Essentially everything, including the brain, is made from these quantum fields, with atoms and molecules existing as specific arrangements within these fields. This means that what we recognize as physical matter is actually the result of intricate patterns and relationships within the underlying quantum fields. In fact, researcher Henry Stapp in 1999 asserted that consciousness might be the overriding force behind brain functions, suggesting that consciousness itself influences the brain. While this idea represents a significant departure from traditional beliefs, it is part of ongoing debates in the field of quantum mind theories. Stapp's view suggests that if the brain is an integral part of a quantum network or field through which consciousness manifests, the brain exists within consciousness rather than consciousness existing solely within the brain. A related idea, cosmopsychism, suggests that the universe itself is conscious. However, Vazza is skeptical. We can't even define consciousness, so it's strange to attribute it to the universe, he says. His study aimed to understand how complex networks organize themselves, not to suggest the universe thinks. Just because two things look alike doesn't mean they function the same. A living brain and a dead brain, for example, have the same structure. Plus, the universe is so vast that any communication would be extremely slow. Philosopher Philip Goff offers a different take in his book, Why? The Purpose of the Universe. He suggests that particles are seen as manifestations of quantum fields. These fields could be the basic units of consciousness. Goff doesn't think this means the universe can think reflectively, but he wonders if this fundamental mind could influence the universe's evolution over time. Whether any of this is true is currently beyond scientific proof. Perhaps the rise of Panpsychism reflects changes in society more than the universe. In the ever-expanding realm of human understanding, our perception of the universe has undergone profound transformations, each era marked by a distinct metaphor mirroring the scientific paradigms of the times. During the Industrial Revolution, the universe was seen as a machine, and during the Digital Revolution, the brain was compared to a computer. As our understanding of the cosmos has advanced alongside technology, we now find ourselves in an era dominated by artificial intelligence and machine learning. In this contemporary context, a new metaphor emerges: the universe as a vast neural network. With growing ecological awareness, it's not surprising that we're turning to more organic metaphors. But the thing is that our brain is made up of a complex network of nearly 100 billion neurons that form 100 trillion neural connections. These neurons are organized into networks of nodes, filaments, and clusters that shape your thoughts, feelings, and emotions. But these neurons make up less than 25% the mass of your brain, leaving the remaining 75% as water. In a bizarre coincidence, the observable universe also contains an estimated 100 billion galaxies. The teetering balance between the pull of gravity and the accelerated expansion of the universe forms a cosmic web of string-like filaments composed of ordinary and dark matter. Galaxies cluster at the intersections of these filaments, leaving empty spaces between them. This cosmic web looks surprisingly like a network of neurons. Interestingly, scientists estimate that only about 25% of the matter in the universe is visible. The other 75% is dark matter. Although the relevant physical interactions in the above two systems are completely different, their observation through microscopic and telescopic techniques have captured a tantalizing similar morphology, to the point that it has often been noted that the cosmic web and the web of neurons look alike. Vaza and Folletti write in their paper, published in Frontiers of Physics. Despite these obvious similarities, the scientists wanted a more detailed comparison of the two systems. They used power spectrum analysis, a technique from astrophysics, to study the large-scale distribution of galaxies. They measured tiny fluctuations across different spatial scales in both a galaxy simulation and sections of the brain's cerebellum and the cerebral cortex. Our analysis showed that the distribution of the fluctuations within the cerebellum neuronal network on a scale from 1 micrometer to 0.1 millimeters follows the same progression of the distribution of matter in the cosmic web, but of course on a larger scale that goes from 5 million to 500 million light-years, Vaza from the University of Bologna in Italy said in a press release. The researchers also compared the power spectra of other complex systems like tree branches, clouds, and water turbulence, but none matched the similarity of neurons and the universe. However, power spectra don't reveal system complexity. To understand this, the scientists analyzed the networks of both systems, comparing the average number of connections per node and how these nodes clustered together. It's impressive that the cosmic web of the universe has more in common with the network of neurons in the brain than with individual galaxies and stars. Similarly, the neurons in the brain resemble the cosmic web more than individual brain cells. However, these similarities only appear when comparing specific scales of each system. This is crucial when comparing something infinite, like the universe, as far as we know, to the finite brain. Since everything in the universe follows the same physical rules, it's not surprising that similarities emerge if you look closely enough. Imagine drawing a circle on a flat, endless plane. You now have two regions, inside and outside. One represents consciousness, and the other represents everything else. If you think the inside is consciousness, you're likely a Western thinker. The circle is the subject, the plane is the object. The circle is small and finite, while the plane is large and infinite. If you think the outside is consciousness, you're likely an Eastern thinker, using these terms loosely. The circle is the object, the plane is the subject. The world is small and finite, while consciousness is large and infinite. For Western thinkers, the circle is like a cell membrane. Objects from the world pass through into consciousness to be understood. Objects outside consciousness are waiting to be discovered. For Eastern thinkers, the circle is like a wall around a city, such as Rome or Jerusalem. Consciousness is outside, trying to get in. It can guess what's inside, but the gates never open. Sometimes an eyewitness sneaks out and describes the city, saying it's like nothing you've ever seen. They compare it to things outside the city, like a tall building or a deep pit, or a combination of a river and a mountain. Science gives us the Western view. It assumes that the mind is a product of the brain, from physics to neuroscience, suggesting we are the universe trying to understand itself. If that's true, we are like the cell membrane, and the universe shares its secrets with us through science. Philosophers have long argued that this isn't true. We are not the universe trying to know itself. We are consciousness trying to piece together what we think the universe is like, similar to archaeologists studying an ancient buried city. Despite this, most scientifically literate people believe science tells us the truth and find it hard to understand why some think scientific conclusions are just biased opinions. Many people here likely fit into this first group and might think rejecting scientific conclusions is foolish and anti-intellectual. However, philosophers have shown there is a tiny grain of truth to the second view, and we all know what scientists think of philosophers. There can be phenomena within a system, such as our reality, that we recognize or believe to exist, yet cannot fully prove or understand. Consciousness is one of those things. Most people agree that they are conscious, and so we have a consensus that this substance called consciousness exists, and yet we cannot rigorously define it, and we cannot prove it. In the Wigner and von Neumann interpretation of quantum mechanics, and in the self-simulation hypothesis developed at Quantum Gravity Research, there is a framework where an observer's awareness or knowledge of something in physical reality forces the universe to update the wave function of that system. As Everett, the author of the Many Worlds interpretation, argued, the only real wave function is the universe wave function. This is a simple deduction because if you take an electron and isolate it from all gravitational, electromagnetic, and entanglement influences, you can write down a contrived wave function for that particle as if it were a universe by itself. But this needs to be more realistic. Therefore, the only realistic wave function is the universal wave function. Combining these ideas every time we observe something in reality, we cause the universe to update or rewrite the universal wave function. This is called the collapse of the wave function, meaning the old wave function is trashed and updated with a new one. The wave function needs updating because quantum mechanics can't predict the unpredictable actions influenced by free will and thoughts, which cause physical changes. For instance, when you think about an apple versus orange, your brain produces unique electromagnetic signals that neuroscientists can detect. These signals affect particles across the universe. Since the universal wave function didn't anticipate your thoughts, it has become outdated and needs revision. This implies that the well-being and choices of one conscious entity can resonate through the interconnected web affecting others, and the overall state of consciousness in the universe. The idea of cosmic interconnectedness evokes a sense of awe and wonder about the universe, suggesting that we are all part of something much larger and more intricate than our individual lives or the collective human experience. Right before you observe something, the updated wave function focuses on probabilities related to what you're observing. For example, if you're watching where a particle hits a detector screen and you expect it to hit a specific spot, the new wave function concentrates on all likely positions into that area, reducing probabilities elsewhere to zero. After your observation, the probability distribution shifts as the wave function evolves until the next measurement. This issue is known as the measurement problem in physics. It's been a topic of debate among physicists for the past century, with different views on whether consciousness plays a significant role in quantum mechanics and related experiments. All this is to suggest that consciousness might play a fundamental role in how the universe works. Many physicists, including John Wheeler, who coined the term black hole, believe that quantum mechanics implies we live in a universe made of information, not matter. This began when he focused on the idea that logic and information are the foundations of physical theory. Wheeler even described the universe as interactive with human minds. So, if we agree that reality is made of information, what is information? Information is increasingly recognized as a distinct physical quantity. Gregory Bateson described it as a difference that makes a difference. Unlike mass and energy, information lacks a specific location in time and space and isn't covered in the traditional sense. It exists conceptually without a physical locus. Moreover, information adheres to a principle of non-ulteriority. It requires no recourse to other concepts for its definition. Edward Fredkin, the father of digital philosophy, inferred that for everything in the world where you wonder what it is made of, the only thing where the question doesn't have to be answered with everything else is information. Information is often discussed in terms of its fundamental unit, the bit. A bit can be thought of as a cell that is either empty or full, akin to white or black, and is represented by numbers denoting emptiness as 0 and fullness as 1. When these bits are processed by algorithms in a computer, they collectively produce information. Therefore, information is meaning conveyed through symbols like code or language. For example, zeros and ones arranged in a certain way can describe instructions in a programming language, like C++. Similarly, the way we arrange letters into words, sentences, and paragraphs conveys meaning. In short, information is meaning conveyed by symbolism. Okay then, what is meaning? Meaning doesn't have a strict definition because it's tied to consciousness, which is also hard to define. However, we know consciousness exists and can observe what it does. For instance, your consciousness interprets the narration in this video, creating new meanings. If 1,000 people watch this video, each individual's mind generates a unique interpretation, resulting in 1,000 distinct perspectives. One function of consciousness is to recognize or assign meaning to symbols. The world around us can be viewed as a symbolic system. We interpret things by comparing them to others, understanding how simpler components come together to form a cohesive whole. Therefore, meaning or information emerges from the relationships between these similar elements. Maybe the quantum formalism is correct in suggesting everything is information, and maybe information is meaning conveyed symbols, which requires a consciousness to interpret. The unique meaning you've derived from this video isn't the pixels on your screen. The meaning has been assembled in your mind from the light hitting your eyes, and it's different for every individual. If we live in an information-based universe, the universe might need to be conscious to hold or realize the complex mathematical meaning of the physical world. The meaning you create from these words is made by your consciousness. If you dream, aren't all objects in the dream made of your consciousness? So perhaps we can say information is meaning without consciousness, an entity capable of creating meaning. Moving on, the traditional view of matter, as described by Newton's Principia, is now seen as an illusion. Matter is no longer considered the foundation of life. Instead, it is part of a continuum involving various evolutionary processes connected to the quantum field. Since everything in the universe ultimately arises from quantum mechanical events, it is believed that the universe is governed by a greater consciousness field overseeing its intricate workings. Understanding consciousness may require an analytical study of higher states of consciousness, forming the basis for new theories and experiments. Through studies of the quantum mind and the exploration of quantum realities, living beings are no longer viewed merely as chemical generators. Instead, they are seen as part of an energy network, a collective field that moves us beyond our separate selves into a unified structure of the universe. This vastness allows us to direct our minds, hearts, and feelings toward the great mystery and wonder of universal existence, experiencing the profound reality and majesty of the cosmic domains of life. Before us lies the mystery of life and consciousness, with the exciting possibility of exploring the universe within each of us. The human journey in the information age has just begun. If we approach it with love, discipline, passion, curiosity, and courage, we can use our greatest tool to explore the world of ideas and the true meaning of the universe. This incredible tool is our birthright. It's called consciousness. Perhaps consciousness didn't simply emerge or flicker into existence. It has always been present, inherent in us and everything around us. The journey towards understanding reality and consciousness is an ever-evolving quest, a continuous exploration that invites us to challenge our assumptions, expand our horizons, and embrace the limitless possibilities that lie in the vast expanse of the unknown. And that's it for this video. Thanks for watching. Check out the other part of this video on your screen.